Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem 762 prime numbers of set bits in a binary representation. So one more easy problem. Given two integers left and right, return the count of number of inclusive range having a prime number of set bits in their binary representation. So set bit means number of ones in a binary representation. Got it? Okay, now recall that the number of set bits is an integer is the number of ones represented when written in binary. Yeah, that is same like number of ones when we represent an integer in a binary format. So for example 21 is written in binary as 10101, so which has set bits as 3, like this one and this one. So we have 3 ones, so 3 set bits. Okay, now let's see the constraints. Constraints are right can be up to 10 to the power of 6, so we cannot have a of n square solution, so we need a solution less than this one, and its value can be 10 to the power of 4. Right minus left can be, we can have 10 to the power of 4. Got it? Let's take one example. So we have 6 to 10, so we need to find the numbers inclusively. So let's take for 6, 7, 8, 9 and 10. So 6 is 1, 6, 6, 7, and then 8, 9 and then 10. So these are the binary representation of this 6, 7, 8, 9, 10. So how many set bits we have here? So for 6 has 2 set bits, 7 has 3 set bits, 8 has 1 set bit, 9 has 2 set bits, 10 has 2 set bits again. So if you see 2 is a prime number, 3 is also prime number. Yes, is 1 prime number? No, so it is false. Is 2 is prime number? Yes. Is 2 is prime number? Yes. So what are the prime numbers we have found so far? This 1, 2 and then 3. So 3 means, 2 means its value is 6, and here 7 is also a prime, and then this is not a, it doesn't have the primary set bits, and then 9 has primary set bits and 10 is also primary set bits. So its size is 4, so we need to return count 4. So its output is okay. So if we clearly observe what we did, so for each integer, so we first converted into binary string or binary format, right? Once that is done, we are counting the set bits, count set bits, and then once we count the set bits, then we will check is that count is a primary number. So is that count a prime number or not? So if it's a prime number, we will simply update the count. So if it's prime number, then update count. That's it. Okay, now let's see pseudocode for this one. So how we can write? So we will iterate from for int I is equals to left to, so these values are inclusive, so we need to start from left and we need to go till right, and then I plus plus. Okay, the first thing we need to do is we need to convert, we need to find the set bits. So we need to convert into binary string and we need to find the set bits. So there are two methods. One is using integer dot bit count method of I, right? We can use this method. So if interviewer is okay with using this method, then we can go and use. Otherwise, so I have already explained in my previous videos how we can find the bit count. So either we can go with that approach or we can directly use this approach. Now for now I will be using this only. So I will use int count is equals to integer dot bit count of left. Okay, so if you, okay, I will come here later. So what is the time complexity of this one? So if you use inbuilt method, it will be big of n, right? Because we will be having only 32 bits, because integer is represented as a 32 bits in Java. So we are going to have a 32. So even if we convert that into binary string, and even if we use a for loop to count the set bits, so it would be taking only a constant time, so it would be big of 1 only. Okay, now once we found the count, next thing is we need to check if this count is prime or not. Is this prime or not? So we'll write a separate method is prime, and we'll check if it is prime. Then we'll simply update the count plus plus. Okay, once that is done, we'll just return the count. Okay, now what is this prime method? So I will write another method called public is, so we need to return boolean is prime. It takes int n. So we already know how to find a prime, so we will iterate till n by 2, and we will check if any, and we will start I is equals to 2, and we will check if n modulo I is double equals to 0 for any I, then we will directly return false, otherwise we will return prime. So why? Prime means it should only be divisible by the 1 or itself, right? Then only it would be called as prime number. Otherwise, if it is divisible by any other number from 2 to n minus 1, then that is not called as a primary number. So that's why we will iterate from 2 to n by 2, and we will check if that number is divisible, then we will return directly false, otherwise we will return true. Okay, now if we check, so here we are traversing from left to right, which is big of n, and inside we are using is prime, right? So what is the time complexity of the prime? The time complexity here, it would be, we are traversing from 2 to n by 2, so it would be of n by 2, big of n by 2. So it is around big of n only. So it would become O of n into O of n, it would be O of n square, so which is not acceptable. Okay, now let's check how we can reduce this finding the is prime. Okay, now let's clearly observe how many set bits are possible actually. So to represent an integer number, as I previously said, we need 32 bits, right? Like 32 places, like 1 0 0 0 0 or 1 1 1, like this we need 32 bits. So how many possible prime numbers can be using this 32 bits? So if all 32 bits are ones, right, so we will only going to have 32 as our prime number. So this is the last bit we can have. So is there any other possibility? No, either we will have 0 count, 0 set bits, or at max we can have 32 set bits. Got it? So we are going to have 0 set bits or 32 set bits. So we are going to have set bits in this range only. So what we'll do is we'll take a set of integers. We'll store these prime numbers within this range, right? 0 to 32. We will store all the prime numbers within this range. So, and we will check if this count is present in this set or not. So if that is present, we are sure that it is a prime number. So what we'll do, I will write down the prime numbers available in this range, which are 2 3 5 7 11, 13, 17, 19, 23, 29 and 39. So these are the available prime numbers in this range. So whenever we are going to check prime number again, so I'm not going to iterate, right? I'm not going to iterate the all time, because we don't need that, right? We are only going to have these many prime numbers only. So I will use a constant, a set of integers. So I can check, so is it a prime number or not in big of 1 time complexity. So it would be easy for us. Got it? So now we'll update this one. Instead of writing a separate method, what I will do, I will just simply check if set dot contains of this count. So if it contains that means it is a prime numbers, then I will update the count. Got it? So now what is the overall time complexity? Just iterating it from left to right, so it would be big of n. Got it? And what is the space complexity? And space complexities, we are using 32 bits, right? We are going to store the 0 to 32 range of prime numbers. So currently they are 1 2 3 4 5 6 7 8 9 10 11. So there are 11 prime numbers available in this range. So it is big of 11. So it is big of 1. So constant time, so constant space we are using. Got it? Now let's code for this. Yeah, first let's define a global variable for our primes to store within 0 to 32 range. So we'll take set integers as primes is equals to set dot of. So what are the prime numbers within 32? It is 2 and then 3 and then 5 and then 7 and then 11 and then 13 and then 17 and then 19 and then 23 and then 29 and finally 31. So these are the primes possible from the range 0 to 32. Got it? Now let's start the main thing. So we'll take a count variable to store the results, and then I will start while left is, we need to iterate till the last element. So left is less than or equals to right, and then what is the first thing we need to check? We need to count the bits. So I will take int variable name, what we can take, bit count is equals to integer dot same method bit count. We need to pass the integer value, so it returns the bit counts. Now we need to check if this bit count is present in our set or not. So our set is primes dot, if this contains our bit count, then that means it is a prime number. So what we can do, we can simply update the count, and then finally we'll update the left, and at last we can simply return our count. Now let's execute this code. It is accepted. Let's submit this. Yeah, it is accepted. If you like my content, please do like, share and subscribe. Thank you.